Good morning, class. My name is Jeffrey Susbilla, and today I'm going to introduce to you the 555 timer IC. But before that, let's review first our previous topic. So our previous topic is all about flip-flop. So what is a flip-flop? Flip-flop, or what we call latch, is a circuit that has two stable states, on and off, 1 and 0 in binary, and it can be used to store state information. And a flip-flop is a bistable multivibrator. This circuit can be made to change the state by signal applied to one or more control input and will have one or two outputs. And it is a basic storage element and sequential logic. So what are the three types of multivibrator? So the three types of multivibrator: first, the astable multivibrator, or what we call free running circuit. The second one is the monostable multivibrator, or what we call one shot or one state. And the third one is the bistable multivibrator, or two state, 1 and 0, or on and off. So today, I present to you this circuit is what we call a stable circuit, wherein it composed of main component: resistor, capacitor, electrolytic capacitor, and jumper wires, and also the 555 timer IC. So today, what is a 555 timer IC? So when we say a 555 timer IC is an integrated circuit, or what we call chip, used in a variety of timer, or what we call delay, pulse generation, or multivibrator or a stable operation, oscillator application, monostable operation. So this IC first introduced around 1971 by Signetic Corporation, a semiconductor company, as the SE555 or ME555. So the ME555 parts were commercial temperature range of 0 degrees Celsius to 70 degrees Celsius, and the SE555 part number designed the military temperature range negative 55 degrees Celsius to 125 degrees Celsius. These were available in both high reliability metal can, or what we call P package, and inexpensive plastic or V package or packages. These full parts number were NE555V, NE555V, SE555V, and SE555V. And it has been hypothesized that the 555 got its name from the 5 kilo ohms resistor used within by Hans Kamensin has stated that the number was arbitrary. The low power version of 555 are also available, such as the 7555 and CMOS TLC555. The 7555 is designed to cause less supply noise than the classic 555, and the manufacturer claimed that it usually does not require or a control capacitor, and many cases does not require a decoupling capacitor on the power supply. Those parts should generally be included. However, because noise produced by the timer or variation into power supply voltage might interfere with other parts of a circuit or influence its threshold voltage. So the 555 timer IC can do the following. First, drive a fuel injector. The second one is drive ignition coil. The third one is drive a relay. The fourth one is drive a flyback transformer, flashing lead, a continuity tester, an alarm, and a power inverter. So this is the actual model of 555 timer IC, wherein it composed of 8-pin terminal. The first pin terminal is a ground, the second one is a trigger, the third one is an output, the fourth is the reset, the fifth one is the control voltage, the sixth is threshold, number 7 is discharge, and the number 8 is VCC or voltage supply. So today, may I call on my co-instructor, Maria Christine Molina, to introduce to you the first third pin terminal of 555 timer IC.
Once again, good morning class. My name is Maria Christine and I will discuss to you the first 3 pins of the 555 timer IC. The first pin is the ground. The ground is connected to 0-volt supply and it is commonly called negative rail or earth rail. And this is the symbol for ground. This. And the second pin is trigger. When the pin voltage falls below 0.33 volts, the timer is triggered and the output goes high. Trigger is an investing input of comparator and responsible for the transition of flip-flop for set to reset. And the third pin is output. The output pulses during a stable operation goes high for a set time in monostable operation. The output is an indicator or the pin where our output voltage is percent. And the other pin will discuss to you my co-teacher Shobie Oral. Thank you.
Good morning class, my name is Shobie Oral. We will continue our discussion all about 555 timer IC. Our number 4 pin of our 555 timer IC is reset. Reset is a timing internal. May be reset by driving this to ground, but the timing does not begin until reset rise above approximately 0.7 volts. Approximately override trigger, which override threshold. The next pin of our 555 timer IC is called control voltage. Our control voltage is the threshold and trigger level are controlled using this pin. The pulse width of the output waveform is determined by connecting a POT or bringing in an external voltage to this pin. The next pin of our 555 timer IC is called threshold. Our threshold is the non-inverting input terminal or comparator, which compare the voltage applied to the terminal which repair voltage. Our last 2 pin of our 555 timer is discussed to you by GP Villanueva, our co-teacher.
So once again, good morning. So I am GP Villanueva and I'm the one to discuss the last 2 pins of 555 timer IC. These are the pin 7 or discharge pin and 8 pin or the positive supply of the IC. So first I will introduce the pin 7 or discharge. Discharge pin. Discharge pin is internally the collector of an NPN transistor. Its base is connected to the output stage of the internal control flip-flop. And the emitter to the circuit is ground. So, as you see in the picture or in slide, pin 7 has a transistor connected inside and its base is connected to pin 3. And if there's a bias voltage on base of the transistor and collector, and its emitter will produce a very low resistance, it means collector and emitter will automatically shorted in ground. So that means the output voltage must be high or binary, or in binary is 1, because because a transistor base requires a voltage to produce a bias voltage. And when the output in pin 3 is low or 0 in binary, the output must be 0 because there is no bias voltage on base. So the last pin is the pin 8, or what we call the PCC or positive supply. This pin is what we call the BCC or supply pin of the 555 timer IC. It must be supplied with a minimum of 5 volts DC and a maximum of 12 volts DC. As you see in the internal diagram of 555, pin 8 has a connection to all stages. So it is the pin 8. As you see, there is a resistor connected into series, and it distributes to other parts of the IC. So that's about the 555 timer IC and how 555 timer IC works. Observe what is happening on the animation. So when C is charging, the output is high or in binary is 1. And after reaching threshold voltage, it will automatically change its state to low or in binary is 0.
The 555 timer IC is very useful and versatile integrated circuit and has probably been unrevealed any linear IC just like op-amp. So the broad application of includes the basic monostable, astable, chemist trigger, comparators, detectors, and common electronic circuit configuration. So this 555 timer is usually available in 8-pin mini dual inline package. And this 555 timer IC is composed of 26 transistors, 2 diodes, and 16 resistors.
Go. Oh, kaalay. Oh.
Kahang sira ulo kang di siya liligaw. Ulit naman. Go siya.
Paalay lang ka ba? Do brush ko na ba?
Kung gawad na. A stable mode. The 555 IC functions as a free running.
Silid ka na steady. Makita ka what ko? Dapat to paspas. Manako daw ang history. Ang valya sa history. Sige, go.
Tangan mo ka sa kwa, kada sa tawag-kwad. Kada sa tawag-kwad sa application, wala lang bigyan. Wala lang eh. Sige na kung diwa. Kaya ko dito kay isang parang